And 6.6. Now we're going to be looking at partial and direct variation. So, last lesson we looked at what partial variation is. Now we're looking at direct variation. So, what do we know about partial variation? We know it doesn't start at the origin, right? This is the origin, and look, R starts all the way up here. So we know this is partial variation. Okay, why? The reason is it does not pass through the origin. What is this? If this is partial, this will be direct. Because, why? It passes through the origin. Passes through origin. Okay. Now, gives us, okay, we can say possible equation here. Random equation. You know what? We're gonna just throw in these ones in here. So, let's see. We have to match these. The creature, comfort, dog kennel costs $20 per day. So, it doesn't have an initial fee, doesn't have a fixed rate, so we know it's going to be our direct. So we'll say the cost is 28 times the amount of days. So this is our possible equation because it's $28 per day. So we know our cost is 28 multiplied however many days there are. If it's 5 days, 28 times 5, and we'll get our cost. Okay? Brana rents a moped while on vacation. She's charged an initial fee of $35 plus $2 for each liter of fuel consumed. So it would be this one because there's a fixed or an initial fee. If we ever see an initial fee, we know it's going to be partial variation. So $2 per each liter, 2 times, we'll say L, plus 35. Okay, so 2 times the amount of liters plus 35. That'll give us our cost. Suppose the daily cost of the dog kennel increases to $56. How will the graph change? So how will the graph change? It's going to become more steep. So instead of being like this, I'll draw it out because we have to do that anyways for this question. It's going to be more like this. I'm going to just draw like a... So it'd be more like that. I drew kind of a dotted line. So that's what it would be like. It's more steep because it costs more per day. Okay, so sketch the new graph. How does the equation change? Cost equals 56 times the amount of days. Okay, so now the initial fee has been reduced to $28, okay, instead of 35. And the price is increased for $3 per liter. So how will the graph change? So the graph's going to change because it's going to start lower, but it's going to increase at a higher rate. So say now it starts here. It'll increase something like this. So eventually it's going to cost more, but at the beginning, and if you don't use much fuel, it's going to cost less. But the more you use, the more it's going to cost. So that's how it would change. It's going to have a lower initial cost, but it'll have a steeper slope. As the equation change, so our cost will be 3 times the amount of liters plus 28. Okay, how are they alike? How are these graphs alike? They both have a slope. I'm just going to say my answers here. So are they alike? They both have a slope. They both have a variable rate. How are they different? I can write this one quickly. How are they different? Well, I'll just say it again. How are they different? One starts at the origin, one doesn't. One has a y-intercept other than 0, one is 0. Right? Our partial variation has a y-intercept other than 0. Direct variation has a y-intercept of 0. How did the change in each situation affect the graph? It changed the slope. Okay, as soon as you change the variable, the slope is going to change. How do these affect the equation? Our variable cost changes. So now we have an example. We have to fill out the chart ourselves. So Jocelyn works full-time selling newspaper ads. She's paid $30 a day plus $1 for every ad she sells. So we have to create a table. So when she sells 0, she gets 30 because that's just our initial cost, right? So we'll go up by 1. It's going to just increase by 1. 31, 32. Now we can graph this. 0. Do this little squiggly. This means you start at a higher number. Right, that way you can have a better kind of proportion with this graph. If we start at 0 and we go up by 10s, you know it's going to be really squished. Okay, so 0 is at 30, 1 at 31, 2 at